Good morning, everyone. Yip will introduce our next speaker. Do you want me to?
No.
I'm sorry.
It's my pleasure to introduce my old friend, Rebecca Weiss. We went to grad school together many years ago. She was possibly the first person I know who was talking about this kind of stuff about machine learning and stuff I had no idea what it was about. She entered this survey research lab, which she changed directions soon thereafter. She has had quite an illustrious career since then. While she was still at Stanford, she started working for Mozilla, and then she, post PhD, became the head of data science at Mozilla for a number of years. Last year, she was at Princeton on a fellowship at the Center for Information Technology and Policy. And now she is the head of engineering. So she has the full view of academia, the pluses and minuses of nonprofits, the pluses and minuses, and the startup culture.
Oh, yeah.
So I'm sure she has a lot of wisdom to bring, and I'm excited to hear what she has to say.
Hello. It's nice to meet you all. I will just repeat what Yif just said with a little bit more detail. So I am one of those interdisciplinary social scientists. I couldn't make up my mind is the way I like to think of it. As an undergrad, I did this degree called Cognitive Systems at UBC, which was psychology, computer science, philosophy, and linguistics. The focus of my time there was on like brains and minds and cognition as a thing. I eventually got into a state where I started to think there's no practical use for what I'm learning. And so I went hard right and went into a technology policy program at MIT. There, I worked with a bunch of people who were experimental economists studying group and decision-making and biases and judgment. So after I went from minds and brains to individuals and groups, I started, as Yif pointed out, getting into surveys because I started thinking about, well, what happens when you start adding all of this up and getting into big aggregate behavior? And so that's when I started thinking about media effects and polarization, but really it was more that I liked big text data and I wanted to find a way to work with it. So in other words, I've had a lot of methods training. I've done fMRI research, I've done eye tracking research, I've done survey methods, I've done in-person lab studies, I've done all of these things. And if you wanted to try to capture some of the questions that I've tried to answer, there are things like, what are the differences between memory and cognition between people? Or how do you measure expertise in a non-uniformly distributed group? And as Yif probably knows the best, how do you estimate persuasion effects for information treatments in terms of like exposure to news or information and then your impact on civic behavior? But also, I had a second career the entire time I was doing this. What Yif doesn't mention is that while I was doing my PhD, I was also actively working at Mozilla. I didn't just become the head of data science. So for all of you PhD students who are thinking of this, don't do this. It's really bad. I have lasting health problems. It's really not a good idea. But I did do it, and that allowed for me to do these things at the same time. So I was able to be first initially just a regular old individual contributor data scientist. Eventually, I started running the team. I moved over into the product organization when I started my own product project. So if you want to know about the tech career lifestyle in those directions, I can talk to you about them. And currently now I am the lead of engineering at an AI startup called Hidden Door, which is trying to turn any piece of fiction into an interactive role-playing game. So from this, instead of methodology, I have some technology skills. So I can build some software. I know a little bit about how to do research and design in an industry setting. And occasionally I am brought involved into some of these policy problems that sometimes enter into the internet realm. And this summer I will be joining the board of the Pew Research Center. So that's just kind of a little fun fact. Okay, so another little fun fact, about 10 years ago, I actually helped put together a similar workshop to this, where I taught a bunch of social science PhD students how to use the command line, how to do basic text processing using R and Python. So it's kind of a wild ride for me to be here 10 years later. So I'm really hoping that I can teach you all something new. Okay, so when Yif asked me to come and talk to you, I thought, well, what should I talk to you all about? What should social scientists be thinking about in AI? So I had a question. How many of you know who Norbert Wiener is? Okay, so Norbert Wiener is somebody who I think you should all know. He was probably, I think, the first computational social scientist. So in the 50s, he was one of these child genius types where he started at like 11, got his PhD when he was 19, worked for the government to do missile defense programs. He was always really interested in how there is a structure in ecological or natural systems and how humans and minds probably reflected some of those similar structures. So the thing that I think is sort of important to know, if you're going to read any of these books, I'd read the middle one. Cybernetics was the first one. It's got a lot of math in it. The second one was the book that he wrote after Margaret Mead and Gregory Bateson were like, can you write this for normal people? And so that's the book that he's written. And it's the intersection of Gregory Bateson and Norbert Wiener, where they really started to bring social science theory into this computational framework that he was starting to develop. He's also legendarily kind of a weirdo. Never took government money after he left the military industrial complex, was very much so against being included in any prestigious groups, one of those quirky types. Anyway, first computational social scientist. I kind of want to give you a sense of just how prescient it was. So this is the diagram of what he referred to as a high-speed electrical computing machine. That those Macy conferences that I just talked about or just presented in the last slide, there were, Turing was there, McCulloch and Pitts, the people who invented the first artificial neuron, they were all there. So it's not like he invented computers. He was just the one who was like, if this works, where will it go to its natural conclusion once we start seeing this in society to a level that we can't really detect the difference between anymore? One of the most important things about Wiener is that he just kind of really believed that almost all behavior is the result of a feedback system, that if you could figure out how to deal with memory, if the memory was like infinite, and if you could figure out the math of the adders and multipliers just correctly, you could predict almost any possible output by a natural system by its input. I also really appreciate that he was really starting to point out the importance of trace data right here, the elements which indicate the performance. So fast forwarding to today, I don't know if you've all seen this before. Who's seen a transformer model in AI stuff? Has anyone? Okay, so I'm not going to bother explaining this. There's tons of tutorials out there that can go through it, but I just find it really striking to compare the evolution here from that original crude tape machine to the state of transformer models. So they're not that different, really, if you take a giant step back. I'm not trying to say that a transformer is just a tape machine, but I think a lot of these metaphors still actually hold. And I'm going to actually highlight a few choice quotes from Wiener's book that I found throughout the years. I've come back to that book a lot to kind of inform myself and give me ideas about what to do next. So I'm going to share a little bit with you, and hopefully that's inspiring to you all as well. Okay, so in the first one, the social system is an organization like the individual, that it is bound together by a system of communication, and that it has dynamics in which circular processes of a feedback nature play an important part. So in his world, he was really keen to make the case that communication between humans consists mostly of producing feedback to a message, and that it's this feedback that's most important to understand how you can control a social system. Again, remembering that he thinks all intelligent behavior can be attributed back to a feedback mechanism. It wasn't possible in his day to monitor all the feedback that an individual was getting the way that it is starting to become possible now. So it's kind of probably preaching to the choir a little bit. I think you all know this, especially as grad students who are in this space right now. We have a lot of data problems in social science. There's a bit of a crisis, I'd even say, going on right now. You have a bunch of options about how you can get this kind of trace data today if you want. You can buy it. There are lots of vendors out there that sell data for you that if you want to buy it, it's very expensive. You might have a lot of measurement error problems with purchase data and you can't do anything about it because you don't actually know how they've measured it, but you can buy the data. You can go into partnership with a platform. Some of you have probably already done this or you've read a lot of papers with it. This I think is actually not so bad, but as we've all seen, especially recently, if you're reliant on an API from a platform, things can change pretty quickly, and it's pretty devastating to a lot of people if that happens really quickly. Plus, if you talk to anyone who's worked with these sharing initiatives, you know that they're slow and that it's a collaborative partnership for a reason, because there's a lot of, it's a slow and long process to get the APIs configured correctly. And the last one, which I'll go into a little bit more in a couple of slides, you can build your own. This is my favorite method because I have some technical skills, but it's also quite hard. You do need technical skills. You also need a lot of money. You need people to help you build things. And it's also one of the only ways I think that I see a path forward for the people to be able to create something that can sustain for a long time without having to beg and borrow from other groups. But that self-sustaining path is actually pretty hard in itself. If you end up having to deal with a lot of philanthropy, which is a different problem. Okay, also, you do have to be careful when you build your own because APIs are now very expensive, like we already just talked about. And it's this scraping practice that we all like to do in the research and science. Like this is kind of a legally gray area. Like it keeps going back and forth. It's just a thing where you can end up in a position where you think you're okay for quite a bit of time, and then suddenly there is a movement to shut you down from like a corporate perspective. And there's not really much you can do about it. And I'm sure you probably know some researchers who this has happened to. Okay, so I already just said at the end there that I'm a little worried about survey methods, and I just told you all that I'm joining the research center. So we talk about this actually. Increasingly, more and more surveys are moving into these opt-in methods, convenience sampling. Now, when Yif and I were in grad school, this was still considered okay. No one really seemed to be, that disturbed. There was some concern about it, but it was more like if the benchmarks are accurate, then we'll be okay. At least I can say, from Pew's perspective, these online and convenience samples are no longer accurate enough to be useful for what Pew's purposes are. And Pew actually maintains their own panel to be able to do the reports that they do because they sit in the probability-based panel slide right there, the little 7%. They used to do probability-based and live phone, and they don't do that anymore. So let's stick with the idea of what polling and surveys are supposed to be doing. We survey people to get access to latent constructs in their head, like opinions and other things that we can't directly observe. But that's kind of a lagging indicator in terms of exposure to information. And there's other issues that all of you who've studied survey methods also know. But even if it wasn't the case that people had problems with remembering things and weren't necessarily truly accurate to their internal states, it's still a lagging indicator in that it comes after exposure. So what if you can combine the two? I like Andy Guess's work at Princeton. I'm a big fan. That probably doesn't surprise any of you if you're familiar with his work, but one of the things I really like about Andy is that he combines this web browsing trace data, which he purchases, with self-report data in order to empirically describe things. This paper is pretty cool. I don't know if you've seen this paper before. If all of you haven't, I recommend you do. But this is something that came out of working with YouGov with something called this Pulse product, which is something that competes with ComScore. So the idea behind this is they wanted to get at latent variables like who did you vote for, and then contrast that with browsing patterns so that they can see if you were sharing fake news and were also more likely to be someone who voted for Trump. This is not a thing you could have done before if you couldn't combine these two things together. So this is an example of how you can use these types of methods to get at questions that you couldn't answer before. Okay, more Norbert Wiener. In the social sciences, we have to deal with short statistical runs, nor can we be sure that a considerable part of what we observe is not an artifact of our own creation. We are too much in tune with the objects of our investigation to be good probes. Again, Wiener came from math and was convinced to look at social science by social scientists. And so he became very quickly aware that unlike the natural scientists, social science is a much harder measurement problem. We are both the instrument and the subject, which means we run the risk of influencing the social phenomena we observe by observing it. So I know we've taken a lot of research methods on like Hawthorne effects and things like that, but I want to also kind of highlight how computer scientists sort of don't care about this and actually sort of exploit it to do other things that allow for them to start using humans as instruments as opposed to understanding human behavior. So here's an example of something that I think kind of illustrates this metaphorically. This is maybe a little timely given last week, but I don't know if any of you have seen this. This is called Purple Air. Do you know what this is? So Purple Air is a company that is making sensors that empower community scientists to collect hyper-local air quality data and share it with the public. So you buy this sensor, you install it on your house, it starts collecting air quality information and it sends it back to this organization. And they're able to then produce this crowdsourced map of people's quality across the country. You know who it's coming from, you know who they are, it's a community, so on and so forth. So the idea here is that because each individual is contributing a measurement back, it allows for you to paint a picture of a gestalt of the entire country's air quality. So we kind of were inspired by this a little bit with Rally, which is the project that I was talking about before. So at Mozilla, one of the things we had was Firefox telemetry. The browser has a bunch of telemetry that's sending constantly information back to Mozilla. And I had this thought of, what if we built more on top of that? What if it was giving more than just telemetry data? What if it was giving content data as well? Well, the problem with that is you have to ask people for it. You can't just take it. So we built this program. So this is no longer, Mozilla's shut this down for a bunch of reasons. But at the time when we were doing this, these are the public facing, the user facing pieces of this. There was a website, you could go to it, it's just a website. There was a membership page, which is where you would go in and you would log in. That's when you would authenticate and make sure you are who you are. Then you would download this extension, which would allow for you to be part of the Rally community. It's kind of like buying that sensor and sticking it on your house. Once you were in Rally, you got to pick who you gave data to. And this kind of two-stage double opt-in is what allowed for us to do the next thing. So I don't know if you know about this, but a couple of years ago, at this point now, actually last year, I guess, who can tell with time anymore? It's months versus years. I don't even know. Anyway, we had a bunch of people come into Rally. They downloaded this extension. They saw that we had this project with the Markup, which is a journalistic organization that does, platform accountability research. And we, asked them, what kind of data do you need from people? And they said, well, we know that there are a lot of hospital websites that have the Facebook metapixel, but we don't know what information people are sending alongside that pixel to these hospital websites. Can you help us find that out? And so we did. And we ended up being able to get, I think it was in the end about 6,000 people to install this extension. It's not representative. That's not the point. We're using humans as instruments. We're not trying to understand their behavior on these websites. And they just kept doing their typical browsing the way they normally did. And every time we saw a metapixel, we grabbed its payload and we sent it back. So this is how we were able to find out that they were sending along content fields of forms they were filling out in a hospital portal. Like, so for example, when you go to register for, I want an appointment with a doctor, here are my symptoms, here's who I am. Some of those materials were getting sent along with Facebook's Pixel in a place where you had probably an expectation of privacy and that this information wasn't going there. So never would have happened if we didn't have this kind of human as instrument approach to getting their data. Okay. Final quote before I get into actual generative AI stuff, before we keep ranting about cybernetics. It's one of my favorite quotes. I actually put this in my dissertation. It's probably the best part of my dissertation, to be honest with you, best written. Society can only be understood through the study of the messages and the communication facilities which belong to it, and that in the future development of these messages and communication facilities, messages between man and machines, between machines and man, and between machine and machine are destined to play an ever-increasing part. So one, I like that it made me feel that I wasn't wasting my time learning all these things and trying to do this research. But I also think he saw a world where eventually machines were going to become intelligent enough and could give the kind of communication feedback that would pass human muster, and that the facilities in which we were going to use to communicate would continue to evolve over time. Like, I don't think he saw Facebook, but I think he saw something like it. So whenever humans are passing messages around, even if it's just to another machine, his point, I take this quote to mean, like, it's always worth investigating the dynamics, the feedback dynamics of that medium. Like, how does that work between human and machine? So some examples of this that I think are starting to pop up, social sharing. So in ye olden days, before we had social media, how would you have gone around trying to measure the information that someone was sharing with another about political events or events in the world? You'd probably need to measure all the conversations they had with every friend and family member that they ever had, as well as all of the news and information they consume entirely on a regular basis. You can't do that. For a lot of reasons, that was not possible back in the olden days. But now we're actually getting closer and closer to be able to doing that. I'm sure this paper is not news to a lot of you. You've probably seen this before. But I like this one because they're connecting, instead of surveys to browsing data, they connected it directly to Facebook profiles to see sharing data. And that allowed for them to do like granular analysis of sharing behaviors, which is what allowed for them to be able to say, that the most likely people who sharing fake news during the 2016 election were conservatives over the age of 65, which is like face validity. I think we all sort of intuitively believe this, but they were able to like actually observe it directly. So I also like that this is a feedback behavior, like you sharing something, you are getting feedback when you share it. And so this is, again, another paper. I like this paper too. It's pretty cool. This one just looked at the words in a tweet and scored them against a dictionary of moral and emotional valence. And so what they showed is that if you are tweeting about a political issue and you have more of those words, the more you have of them, you can see that effect. It's pretty straightforward. The more you have, the more likely it's going to get retweeted. And this is, again, another example of using information that comes from a platform, but really you're looking at this kind of feedback mechanism that is driving behavior. And does this actually end up predicting any outcomes, like real civic outcomes? Do you become more likely to believe in these issues? I don't know. They didn't go that far, but it is more likely for it to be shared. Okay, let's switch gears a little bit. Why am I ranting about cybernetics and feedback and all of that when this is supposed to be about generative AI? So I just wanted to first start off by refreshing you all by how did we get here to this moment in time? It's actually a pretty long path, it's like 75 years. Wiener was at the very beginning, along with all of those other early AI folks. And now we are here. And I think that in the beginning, the belief was we're going to be able to simulate messages and feedback that could pass as another human. Now we're kind of actually here. So this has been kind of a long time in the coming, but I think we're finally at that precipice moment. So question before I keep going on. Who here knows what a foundation model is? Does this mean anything to anyone? Okay, GPT, you all know what GPT is? GPT 1s through 4, that's a foundation model. Stable diffusion, anyone knows what stable diffusion is? Have you seen this? How about Midjourney? So Midjourney is like a Discord where people are using it to generate art. So Midjourney has their own private model that no one really knows, they're doing it themselves, but Stable Diffusion is an open source image generating model, and that's another one that's a foundation model. So the reason why they're called foundation models, because they're really dang expensive to make. They cost millions and millions of dollars. That left side of this model is like hundreds of millions of dollars in GPU fees. No one is casually going to do this on their own. That's why they're called foundation models. Once you have a foundation model, you can start doing more to it. You can fine tune it. You can use zero or few shot training to try to adapt it to your specific use case. That's what's happening on the right side there. But for the most part, you know, that's the other half of the gold rush. Usually you'll see people on one side or the other. And, you know, my off the record, even though it's not really off the record, opinion is that for the most of the opportunities out there, it's going to be on the adaptation side than on the training side. Unless you are a hardcore computer scientist, the training side is just now commodified. Like it's like you have to work for one of these big tech companies or find someone who'll give you a couple $100 million to do it. So good luck. Have fun. If you want to know more about foundation models, the Stanford HAI, forget what the H is, the artificial intelligence group, it's down here on the top, on the bottom right there. They have this really good long paper about it if you wanted to learn more about it. It goes into the economics and all this other stuff about it, the energy usage if you want. Anyway, it's a great paper. So I wanted to give you all a couple of things to know as you're learning more about LLMs and hearing them in the press and hearing stories of people talking about AI. Like there's two kinds of terms of art that, at least for LLMs, I think you all should know. One is parameters. So when you see this is like all of the big LLMs and most of the foundation models that have been released in the last couple of years. And you can see that the y-axis is the number of parameters, right? So this, you'll see someone say like ChatGPT is, you know, trained on, or is using GPT 3.5 turbo, which is 170 billion parameters. What does that mean? Who here remembers the parameters of a Gaussian distribution? It's the mean and the standard deviation, right? With the mean and standard deviation, you can describe a symmetric Gaussian distribution perfectly. And this is kind of what parameters are for these models. The difference is it's not a Gaussian distribution, it's a language model. So you need billions of parameters to describe all of the nuances of human language, because you're not trying to describe a linear function, you're describing all of the distribution of language for people. I actually don't think that there's like, it's actually quite hard for me to fathom the idea of billions of parameters coming from like a very basic statistical training. Like, I'm not a hardcore computer scientist. So the thing that I will tell you is that most of those parameters are not like means and standard deviations. They're things like vectors and vectors of all of these different rates that they've decided, like if you change this dropout rate, or if you change this learning rate, like those are some types of parameters. The layers of a neural network, those are parameters. So this is how they get to billions and billions of parameters, just throwing everything in there. Largely, the belief is that the more parameters, the better. Another thing I want you all to think about is tokens. So this is another thing you'll see a lot in LLMs. They'll talk about it in two ways. They'll talk about it in how many tokens trained a model, which is an indirect function of the total vocabulary of the model. Then the other one is the input or the context window. This times gets interchanged a little bit. This one, for all of your purposes, if you're on that adaptation side, if you want to actually start using foundation models, you need to know this, because this limits the amount that you can put into a prompt, and it also limits the amount that you can expect it to produce, unless you give it very specific instructions. And there's tons and tons of tutorials out there that can help you with trying to like hack and optimize your prompts. But largely speaking, the token input window is the limitation of your LLM in terms of how much data you can feed it. So to give you an example, this is a very simple prompt, right? This is a prompt that's trying to teach you how to build a movie sentiment classifier. And all you're doing is structuring it in a specific way. You see how you can actually give a prompt some structure, like those little boxes are trying to get you to show that that's actually a template that you're telling the model to start seeing. You can instruct it in this way. So this is called few shot learning. You're giving it a few examples to learn from. It's already been generally trained. It's that massive foundation model. And now you're giving it a few more examples to train from. So the context window here is everything, right? So everything from that initial top prompt and everything coming out of the completion, that has to fit within that token input window. So what does that mean right now? So here's some benchmarks to give you a sense. These are the most popular LLMs out there right now, as well as a couple of open source ones. So to go from left to right, those token limits that I just talked about, that's on the left side, right? So roughly speaking, 4,000 tokens is, I think, about 8 pages. So this is about how much context you can fit into a single prompt. Eventually, you will see this if you've been playing around with ChatGPT or any of the LLMs. After a while, it starts to like lose the thread. That's why, because it doesn't have enough context window to be able to maintain state of all of the things that you've been talking about. So all of these people have come up with lots and lots of hacks, things like be concise at the end of every prompt to try to make it as short as possible. You can literally say this, be as concise as possible. Or you can use a summarize function at the end of something so that after you've had a long chain, you can now summarize everything that we've talked about, and then you can use that to feed into the next prompt chain that you start. But that's the way people get around this token limit. I will also tell you there's another company out there called Anthropic that has this model called Claude. I don't know if you've heard of this. It's a competitor to ChatGPT. They recently just claimed they have 100,000 token limit, which blows my mind because that's a book. You could give Anthropic a book as part of the, or you can ask it to write a book. Like it's just crazy to me. Anyway, the token limits here, the thing that you need to know is that the complexity goes up exponentially with more tokens. So that's a real hard problem in computer science. That's like where you get into hardware problems, where you start thinking about how do I fit all of this memory into a vector representation with only X amount of RAM. Like gets to be a bit much. Like the linear algebra there gets to be very complicated. On the parameter side, you can see how some performance seems to be related to how many parameters you've got, right? Like these 3 columns on the right, MMLU, hella swag, because computer scientists are funny. And ARC-E, these are multiple choice knowledge-based tests. So MMLU, you've probably seen these examples of ChatGPT can pass the bar exam or things like that. MMLU consists of a set of questions that are all true or false coming from a bunch of different tests. It's a standardized metric. So you can see that you can think of those as like grades. How would you pass, right? So there's a couple of other benchmarks out there. I just chose these 3 because they're some of the most popular ones, but there's truthful Q&A. So you can give it true false questions and see how many it gets right. Like there's dozens and dozens of these benchmarks. And just so we're clear, I'm going to put a little peg here for you all. This is one place where I think social scientists should be more involved, because I think right now they're just factual based. They're just looking for, Boolean outcome, like you either did or you didn't, so that you can get these types of truthful metrics and then people can interpret them very directly. But these are just looking at knowledge-based indicators, not looking at behavior-based, benchmarks. So it's just a thing that I want to leave in everyone's head as a seed. The other things I want to highlight here at the bottom, Llama is Facebook's model. That one's open source. So that's the most popular open source version that is made by a big tech company. So you can see its performance is not that great on that MMLU metric, but on the other ones, it's definitely competitive with some of the bigger models. That bottom one, Falcon 40B, that is currently the top performing open source LLM that is not made by a big tech company. Instead, it's made by the UAE. And I do mean that, the country. I forget what TII stands for, but that's an institute there that is trying to create an alternative to these big LLMs. But as you can see, it's not that great. It's pretty good for this kind of like common sense task, which is indicated by that HelloSwag indicator. But in all of these other knowledge-based tasks, it's still not that good. Importantly, also, it has a very small token limit. So it's pretty hard to use it for a lot of bigger scale applications. However, for applications like maybe you're a researcher and you just need a cheap model to like do a rote task for you 1,000,000 times, that one might work and it's free. You do have to be a little bit more technical to work with it, but there are tutorials out there. Okay, so I want to take a pause here for a second and show you all some things. Here we go. Let's see if this works. Okay, so I wanted to show you all, this is probably pretty small, huh? Is that better? Okay, let's put this here. So, how many people have tried to do anything with, have you tried ChatGPT? Has anyone given this a shot? Okay, so clearly you've all tried it. So you're familiar with the interface. It's just a chat window. I'm sure you've all probably thought, how do I get this to do something that isn't through this chat window? Has anyone tried using GPT directly? Okay, so you have. All right, so this is old news for you. Microsoft has this SDK out there called Semantic Kernel. It's a library. I don't know if you've all been playing around with Python lately, but I'm going to walk you through this a little bit. So if you download Semantic Kernel, you get a lot of pretty useful functions for free that mean that you, as the person who's just trying to build some script to do something, you don't have to deal with managing requests. You don't have to deal with API management. It kind of has made all of this happen for you. That is with a couple of functions. So this one right here, OpenAI settings from .env right here, and don't copy this. I have to make a new key now that I've just like leaked it all to you. This is a secrets file, basically. This is your environmental variable. When you go to OpenAI and you request an API key, that's how they bill you. So if you use Semantic Kernel, you just create a .env file right by your Python file, and it knows to read it from that information. So that handles all of your securities and your secrets management for you, which I will tell you is really helpful, because then you can just add this file to like a git ignore if you're trying to use GitHub. And that way your app will be perfectly stored in your repo, but you don't have to worry about leaking your keys online. So it's a very useful thing for them to do that for you. So that handles your authentication. This function right here is what allows for you to add text DaVinci 003. This is GPT 3.5 Turbo. That's the other name for this model. Anyway, the point of this function is it's just allowing you to say, this is the model I want to use for the task I'm about to do. So then I'm just going to show this for you really quickly. So this is that example that I just showed you in the slide, right? Here I am giving it a couple of templates saying, I want you to give me the sentiment of the last movie there. So I'm going to play it and watch this right here. This is my terminal. There you go. So it's that fast, it's that simple. I think you all can see that at least that's one way you can start integrating this very quickly into whatever tasks you're doing. Semantic Kernel has a bunch of other functions for you. I'm going to show you another example. This one's a little bit more complicated. So this one involves me starting this service in the back. because there is a web app that they've built for you. This semantic kernel library comes with all of these tutorials, as well as a bunch of notebooks if you prefer notebooks instead of developing through this kind of Python interface. So you have options if you want to learn. There are many other ways that you could go about learning how to use foundation models or GPT models. I just think semantic kernel, because it's from Microsoft, that means it's well supported. It will have documentation. If you file issues in their GitHub, they will respond to you. So there's a community, they have a Discord. So if you wanted to start using it, I think this is probably a good place to start. Just don't learn C#. It's Python and C#. Just don't learn C#. It's just not worth your time. Anyway, unless you want to become a developer. So I will now show you an example of, actually, I'll do it here. I'm going to show you book creator. All right. Same thing. If you download this tool, if you start using this SDK, all of this is there for you. You don't, like all of this code is already, I didn't write anything. I tweaked like one little file because it was doing something wrong. Anyway, let's show you. So you can see these functions here. These are functions that semantic kernel gives to you. So you don't have to come up with these functions. You could just look at the things that they've got. They call them skills. These are basically functions around AI service. So let's do, let's do the Wizard of Oz. That's this right now. That's a query. That's an OpenAI query. It's trying to generate ideas based off of this prompt for me. In the back end, this application is now parsing the content coming from this, and it's processing it for this web app. So now we wait. If you want to see what's happening on the back, you can watch the server. You can see that it's actually invoking these functions. It's making this stuff happen. So now we have the options here, the Wizard of Oz. Let's just pick one, see how long that takes. This time I will show the process here. This is all live, so you're getting a sense of the time on this. I'm using my free account. I'm not using ChatGPT. I'm not using GPT-4. I don't have pro accounts. This is all the lowest level. So this is the prompt. You can see right here. I don't know if that's actually, let me make this a lot bigger. That's the prompt that it was sending to the LLM. That's how long it takes. This was crashing over the weekend, so I hope it doesn't crash. Here's another thing to know as we're waiting for this to happen. OpenAI as a service from like a software professional perspective is really bad, goes down all the time. Like the API is always going out. You can't build reliable service on it. It has like no uptime. It's like constantly falling over. It's still going. Yeah.
With the validation, how do we know that we weren't trained down?
You don't. I mean, the Stanford ecosystem of LLMs, it's part of High. They have a really great website that tracks all of the open source models as well as all their dependencies. And by dependencies, I mean, what data were they trained on? So you can see, there's one very famous data set called the pile, which is a bunch of stuff from Common Crawl and a bunch of other public domain data. Nobody really knows what GPT is using.
Once someone tests it, is that information then incorporated?
I wouldn't put it past them. But the thing about the model is that it's probabilistic, so it still might get some things wrong depending on how it's prompted. But there is a very lively career in computer science for people who do nothing but benchmarking all day. So you can read all their papers to see all the different tricks that people have come up with. Okay, so this finished. So there, just wrote me a book. I don't think it's a very good book, but it is a book. Right? So now you can imagine, like you saw how long that took. This is not, it took like a minute. Let's make it in the style of a surfer. See how long that takes. Let's go back into the process. So you see how it's writing this, it called this rewrite function that exists. It's already a thing. It's under the writer skills under a semantic kernel. So if you decide you want to build something and you want anything under writer skills, it's already done for you. Okay, so let's see what this looks like in the style of surfer. You see it's much faster. Let's see what's happening. Still going. So each one of those pages, it's trying to rewrite it. You can see how it has these inputs at the bottom of key value style surfer. So that's that function. It requires those variables in order to be able to do that rewrite. And again, all of this is documented if you wanted to, right here. It goes to show you that. There you go. Let's shred. Right? Pretty cool, huh? And yeah, this is a much more complicated app. If you wanted to look into, like, there's a lot of web app stuff, which is why, like, I warned you, that's like a much more complicated example, unless for some reason you want to build a web app. Otherwise, I would say go look at their notebook examples because they have a bunch of them. Okay, let's go back to okay, so successfully demoed something for you all. Hope that was useful. Okay, that's not really social science though, right? So here's an example, and you're gonna laugh, Yif, because this is Saul's recent paper. I thought this was really clever. They recognizing that GPT essentially is a representation of all commonly accessible knowledge on the internet. The authors decided to investigate whether you could use GPT to construct scores of ideal point estimation that would mirror things that we already use in political science. I think it's pretty good. I mean, that's a pretty good relationship right there between chat scores and DW nominate. The protocol they used was pretty straightforward. As you just saw what I was doing, they basically asked 15,000 pairwise comparisons of prompts of the phrase, roughly speaking, who is more liberal, this senator or that senator? And they did every single permutation of all the Democratic senators and every single permutation of all the Republican senators. And then they used a ranking algorithm in order to construct two-dimensional scores that would then allow for them to look at something like a comparison against DW nominate. So why do I think this is interesting? Is it social science? I think it's social science. Even though you're just interrogating an LLM, in some ways you're back in this world of Wiener, right? You're back in this cybernetics world where you're looking for feedback from a social system. In this case, it's all of this collective knowledge that's contained within this model. And then as social scientists, instead of interrogating the people directly, you're interrogating the model for that information, which I think is sort of a fascinating flip. So I think it's kind of an interesting place to start thinking about ways that you can extract social information from these LLMs. Okay, my last comment, which is more of a rant. I think there's been a lot of discussion about AI and how it's going to affect the labor market or industries, or do I have a future career? And I have to admit to you all, I've been thinking this, like, do I have a job? Like, I don't know. Seems like these things take over my job pretty quickly. So this, I love this quote because Wiener was actually he could be quite sharp if he needed to. The future offers very little hope for those who expect that our new mechanical slaves will offer us a world in which we may rest from thinking. Help us they may, but at the cost of supreme demands upon our honesty and our intelligence. The world of the future will be an ever more demanding struggle against the limitations of our intelligence, not a comfortable hammock in which we can lie down to be waited upon by our robot slaves. But I'll tell you what, I think this hype is real. I think in the past couple of years, we've been hearing a lot of things about crypto and a lot of things about other technologies out there, but I want you to look at this adoption rate. This is GitHub stars. This is from Andreessen Horowitz. It's a VC company or VC firm. All of those other projects you can see are related to just, Kafka and Spark, those are just general computer science tools that have become very, very, very popular. They had their heyday. Obviously, I'm pretty confident you all know what Bitcoin and Ethereum is. But if you see Stable Diffusion all the way on the left, that is a ridiculous adoption curve. And that's open source, right? So anytime you have open source with an adoption curve like that, it's going to go, there's more projects that will come out of it. So this is another way of me saying, y'all should learn these skills. Do the tutorials, like try to build some things. As social scientists, I think I've heard a lot of folks who are familiar with the old world of ML, where it was still quite dumb. And I would say LLMs are still quite dumb, but they're definitely a lot more useful than I think people realize until you start working with them. And then it's like, oh my God, they really are. This is not a joke. Okay, final comments. So in light of all this, what should social science do? Again, I love quoting Wiener all over the place. It's my thesis that the operation of the living individual and the operation of some of the newer communication machines are precisely parallel. What a statement. It's pretty bold. 3 comments, 3 takeaways for you all that I kind of hope that this kind of inspires you in your careers for the next decade, because I can speak from prior experience. Like I had a moment like this and it informed my next 10 years. So I hope this does the same for you. 1, I think we need new empirical methods of measurement. We've been relying upon traditional ways of doing empirical measurement, and I think we need to start becoming very creative. A lot of that actually involves understanding software at a level that I don't think is common in traditional social science curriculum, but I think we're all going to need to start moving into that direction. The Journal of Quantitative Description, I think this is a great journal. I wish this existed when I was a grad student. I would have submitted to it all the time. I strongly recommend that you consider it. This paper, Rebecca Tremblay has been doing this for a while, pointing out that partnerships are not really going to answer all of our questions, and that increasingly we are kind of in a crisis mode. And so I recommend reading this paper. It was just published. I also just think we all should be thinking a little bit more about what does the world look like if we're not going to rely so much on survey research methods as a way to describe representative populations because there are problems, or if they become not useful for social scientists who can afford lower quality, to be blunt, convenient samples. If they become not useful, like what are we going to do then? I also think that this idea of trying to create separate institutions that are data centers of their own in some way, intermediaries between platforms and others, I think remains viable. Europe is actually going to push on this. Article 40 of the DSA sort of mandates it. So there's going to be a lot more opening there. The second thing is a little bit more nebulous, which is more like, I want you all to start thinking a little bit more about how in 2 to 3 years, social platforms are going to look very different, and there will be new social platforms and there will be AI everywhere. Like I really think this is happening at an incredibly rapid rate. So think about this new world that we could be living in from that kind of cybernetics framing of information, messages, feedback, and control. I think this can be sort of a way to start thinking about a research question in its very early stage, meaning it's always going to matter what messages are important. Some messages are always going to be more important than others. And the communication facility in which they are embedded provides the feedback mechanism. So if you think of it that way, then you can start thinking, well, how do I build something in order to measure that feedback mechanism? The last thing is team up with algorithmic auditors. So this is a group in computer science. I think Danae here is also, yeah, so there's a lot of this happening in computer science. I think this is a place where social scientists should team up, because computational social scientists from the social science background still always come from a theory first sort of way of thinking about a problem. Whereas computational social scientists coming from a computer science background think about, well, I can make that thing. I can do that task. I can, investigate that algorithm, but it might not necessarily be connected with like a theoretical or substantive contribution. So going back to, for example, what I said earlier about, I think we need more benchmarks that aren't just about semantic truth knowledge. Like this is a place where I think social science could get involved. Like what are these new benchmarks that we should be thinking about that are instead about the behavior of an LLM with another person, as opposed to the behavior of an LLM on its own. There are a lot of people who do algorithmic auditing. I just left a couple names there, but if you start looking into this, I think that there's quite a bit of collaborative energy I think that social science could get into if they worked with the auditors. Okay, that is it. Q&A. Literally anything. Except it's recorded, so, mind yourself.